As a follow-up to this video that I posted on a 386SX upgrade, I was able to track down some information in the 386 hardware reference manual that talks about generating the S0 and S1 signals from the MIO, DC, and WR coming out of the 386. So that was an outstanding question I had. Was there a direct type of connection? And clearly looking at this, that's not the case. So they do have some logic here. And I'm looking at this and I'm going to approach it taking out the chip select and the WS, at least for the initial version. I don't think I need those. I could be wrong, but I'm going to assume I don't have a chip select that I need to worry about. I have a single processor. I would think this would be if I had a multiple processor or something like that. I'm not sure why I would need a chip select. And then the WS I assume is for wait states, and I'm not doing anything with wait states today, so I'm going to try an initial version without that. So what I've done is I've gone in, and actually I've even updated it from this graphic, and I'll switch over to it shortly. But I'm going to put a PLD, specifically a GAL chip in the middle here that will do that logic to generate the S0 and S1. And I quickly drew this up. I'll have to go back and double check that. Nice thing with the GAL though is if this logic isn't quite right, I can tweak it and adjust it later and not have to worry about changing the physical design of the PCB. So this was the PCB I had previously shown, but here's the new update to that. So this is what it now looks like. I did dial things in a little bit, so you can see I cleaned up the board itself. This is the PLD right here in the middle. So if I go to this view, I did go with a GAL 16V8. I've been using the 22V10s quite a bit in the past. I have not used the 16V8 before, but it seems like the logic that I'm trying to do here is so simple. I just shrunk down to a smaller one, which I think will be fine. And I have some 7LPs, so those are pretty fast and should be able to do whatever I need to do here, I think. But that's my goal, at least, is to try doing that. And so the design that you're seeing on this other page that I was showing here, I laid that out in software called Digital, and that software lets me directly create the file to burn to a PLD. So it saves a whole lot of hassle. And actually, if you're ever interested, I do have a post on my blog, and let's see if I can find it here. I think I've got it titled GAL. So if you search for GAL, you'll find this post where I talk through using this digital software to create these PLDs. But the nice thing is that this digital software can directly create this JEDEC file. And it means I don't have to go use terrible software like this WinCouple, which I've never liked and definitely is not a friendly tool for me. But the digital lets me just graphically lay it out, lets me directly create the JEDEC, and then using my regular programmer just burn these PLDs. So that's been handy. And the digital software supports the 22V10 and then also this one that I have over here, the 16V8, I believe it supports. I've not done that one before, but I believe that is in the supported versions, those two. And so then again, the logic that I have over here is just taking this and I think basically boiling it down to this, which should be comparable if I take out the chip select in WSW1. The other question I had was on this PEACK signal. And I did find in the hardware reference manual, it also mentioned that that's not needed when I go with the 386SX, because that 386 is a little bit more intelligent than the 286 was, and it doesn't need to use that signal to understand how much data is being transferred. So this is the design I'm going to go with, and this should be updated here at this point to support the GAL. And if I go back to the schematic, I've got plenty of open pins still on that. So if I have to do something different, if it ends up that I don't quite have this right, I should have some flexibility to adjust here on this PCB. And it ends up the PCB, I went 4-layer. And so if I go back to the design of this, this is a case where I went 4-layer. There was some previous discussion on 2-layer versus 4. And this board is so small that the 4-layer only ended up being $7, I think, for 5 of them. So I think the size of it is making a big difference. It's small enough that the 4-layer is affordable. And then I'm shipping it the really slow route, which is, I think, under $2. So I'll have $9 into $9 into a set of these. So if they're not right, I don't have any heartburn about it. But if I have enough of this to actually connect this together, which I think it's got to be pretty close, I hope, then I can work with this. And if I do need to do something extra with the gal, I can just solder wires directly on the bottom and connect to anything over here on the 286. However, if it's on the 386, I would have to solder just to the very edge of these pads if I had to directly connect something. Doable, but hopefully that won't be needed. I did also update all my capacitors to surface mount, and these are actual capacitors that I have. So a 0.1 and a 0.01 pair for, I just put a pair on each side here. And then I've got some, these are some tantalum, and I think they're 22 microfarads that I have on hand. I'll just put maybe 4 of those, one in each corner here. So there should be plenty of that surrounding this. And I am no expert on these capacitors, so I'll be experimenting a little bit with this. So if anybody has feedback on that, do let me know. But I've had good success with the pair of a 0.1 and a 0.01 on my ICs. Normally I do through hole, but in this case I'm going to try surface mount, which means I did have to also order up a stencil. One thing I've noticed about ordering stencils from JLC PCB is that ordering stencils gets really expensive. The stencil itself, maybe is about the same price as the PCB, another $7, but then it significantly increases the shipping price, and the cheapest shipping then at that point is $20, $30. Because the stencils are quite large, and they ship them nicely. They put them in, they sandwich them between a couple of boards and ship them out that way, but it's just really expensive. So I ordered off a different website just the stencil for the processor for this 100-pin format, and I'm not worried about the caps. I can do all that manually and not have any problems. So that is what I have for this design, and I want to give it a shot. When I look at my 286 itself, let's just say I pull up a picture of that real quick, just from, maybe I'll come over to this and use this as a picture of it. That board will fit, and it should fit and still clear this P-sock that I've got sitting here. And so it's going to come over and basically fit in right here. And really the only chip I'm going to cover up is a single chip here that I don't ever think I'm going to need to touch. So it may be that I just directly solder that in to the board when I get it, or put it into something that I can pop out. We'll see when I get it. I'll have to play around with that. But it's been ordered, and it's ordered in the 30-day delivery type of window, so you probably won't see any update on it for quite a while. But when I do get it, if I can get that 386 on there and get it in here and see if it actually works, I will post some updates. Whether it works or not, I'll post updates and let you know what I've learned.